Hello, my name is Colton Schnaitter and I am a digital design engineer with IntelliProp. Today I will be introducing you to our NVMe Target IP core. So an IP core is a licensable logic function that can be used as a building block within an ASIC or FPGA design in a wide variety of applications. IntelliProp's NVMe Target IP core is an NVMe function that provides connectivity to an NVMe host such as a PC or server. So today I'll be covering an overview of the NVMe Target IP core, including where the NVMe Target IP core can be used, the key features in the block diagram. Then I'll show the hardware setup for the reference design and run a brief demo. And finally, I will review the performance of the demo. IntelliProp's NVMe Target IP core is an industry-standard NVMe target interface that provides a solution for high-speed transport-agnostic data movement and storage. With an easy-access, open back-end interface for command handling as well as data transfer and management, the NVMe Target core allows for various user-defined implementations of data applications. So the NVMe Target IP core can be used in several locations. It can allow customers to create NVMe SSD controllers, NVMe fabric devices, or NVMe bridge systems. Included with the IP package is a hardware reference design with scripted flow for project creation, synthesis, and implementation, a set of reference firmware, encrypted HDL for synthesis and simulation, support for a model sim verification model, and 6 months of support. Here we have our block diagram. On the left is our PCIe endpoint core. On the bottom is the NVMe Target core, which fetches submitted commands from the submission queue and posts completions to the completion queue. It handles solely commands. On top is the hardware data path, which handles read and write data for read and write commands. That data is stored in DDR in the reference design, which is dealt with via a DRAM controller. The CPU on the bottom right handles all non-read-write commands, such as admin commands, format commands, that sort of thing. So the key features of the Target core are that it is fully compliant to the NVMe industry specifications, has a complete NVMe register set with user back-end system registers, has parameterizable and configurable interface features such as queue depth and number of supported queues, automated opcode decoding and filtering, automated completion entry management, user interrupt generation, automated host interrupt handling, and system bus interface implementation for easy integration with the user system. So here we have our demo that I just started. What we have is our NVMe Target core reference design set up on a VCU118 development board. This is connected to our host PC. The host PC itself is running a FIO script using the FIO benchmark tool that runs a series of read and write commands targeting the NVMe core as a block device. And on this side here, we have our UART debug prints from the hard processor in the reference design. So in the performance for this demo, you can see that the performance maxes out at about 2.5 megabytes per second for both reads and writes. So today, we outlined some of the features and benefits of the NVMe Target core and demonstrated the performance capabilities of the IP. The key points of the NVMe Target IP core are high throughput hardware acceleration, simple user interface and easy system integration for reduced development time, and scalable and configurable design for any application. If you'd like to contact IntelliProp, you can find us by email at info@intelliprop.com, by phone at 303-774-0535, or on our website at www.intelliprop.com. Thank you for watching.